All right, welcome to Wednesday's class, the middle of the week. Yesterday, we finished lesson 1. It was a long lesson. It was all about conversions. I went through every question of the assignment, so you can look. You can look on yesterday's video and see if you have any questions on the assignment. You can just look on the video and you can get all the answers are done. So we're actually going to start lesson 2, two-dimensional shapes. I've made reference to them a few times. Two-dimensional shapes. That means we're measuring a space now. We're measuring in 2 dimensions, and I referenced that yesterday. We talked about if I'm measuring a carpet for my living room, I need to measure not only the length, but the width of the room, right? Because I have to, a living room carpet would be a shape, usually it's rectangular or squarish. So it's a shape like this. So I not only need to know the length of my living room, but when I go to the store to buy the carpet, they're going to ask me the width as well. So that's a two-dimensional shape. Two-dimensional shapes, they're easy to recognize because I have to measure. I have to take my measuring tape out and measure one way and the other way, but also two-dimensional shapes are flat. Okay, they're not three-dimensional. Three-dimensional are obviously 3 dimensions. They're just flat. Two-dimensional shapes usually refer to things with lengths and widths or base and heights. The surface of your desk or like a piece of paper has 2 dimensions. A flat wall has 2 dimensions. So there are many things that are 2-dimensional, and we'll get into them, but they are the 2 dimensions. Just think of how, if I wanted to get a scope on the size of this object, how many different directions do I have to point my measuring tool? All right, the following are common 2-dimensional shapes, and we're just interested really in the common shapes when we get deep into this unit. Today, we're going to see a few odd-looking shapes when we talk about perimeter, but most of the shapes we deal with from here on out after today's lesson will just be the regular shapes of a rectangle and a square, a triangle and a circle. So those are the 4 common shapes in design and measurement. By the way, squares and rectangles are very closely related, right? A square is a special kind of rectangle. It's just a rectangle with all sides equal. Now, if you think about it, these are the basic shapes, and we could make many other shapes up just using these 4 shapes. We see these shapes everywhere, but you can never hold one. It has no thickness. They only appear on flat surfaces because we live in a three-dimensional world, correct? Even a flat piece of paper has a slight depth to it. So we're just talking about 2 dimensions. This is really important just for today. Most of our work is going to be done, like I say, from here on in subsequent lessons with these 4 shapes. But it's important to note that a 2-dimensional shape does not have to be one of the common shapes shown in the chart. For example, this funny looking shape is not one of our basic shapes, but it's 2-dimensional. And the reason it's 2-dimensional, even though I guess my ruler would be pointing in slightly different ways, I'm really only going either sort of in an upward down direction or across the page. And there's a better definition here on the top of page 13. Any 2-dimensional shape is made up of a series of lines or sides, because a circle also is a flat shape. The lines themselves have linear measurements. They can be measuring using standard units. However, the shape created by those lines has 2 main types of measurements associated with it. Okay, so each 2D shape, what we're going to do with 2-dimensional shapes is basically find the area and find the perimeter. So the perimeter is very easy. If you think of the perimeter of Winnipeg, the perimeter of Winnipeg is the highway that surrounds Winnipeg. So if Winnipeg was in the middle here, the perimeter highway is essentially, it's not a perfect rectangle, but it's a system of highways that encloses Winnipeg, and that's why it's called the perimeter highway. The perimeter of a two-dimensional object is the linear distance around the outside of the object. Now, the interesting thing is there's no formula for perimeter, except for circle. We'll see that on the next page. But you simply just add the lengths of all sides. So knowing that this is a rectangle, what you're supposed to know about a rectangle is the opposite sides are equal. And I can show that by putting a slash. If I put a slash here and a slash here, I'm telling you that both of those sides are equal. So if I need to, I can record that that's 2 centimeters. And a rectangle has opposite sides that are parallel. So this is 4 centimeters. If I use a double hashtag, I can use the same double hashtag here. And I know that this is 4 centimeters. Okay. The reason I can't just use the single hashtag is my symbol for 2 centimeters. So I have to use a different system of hashtags. So a rectangle has opposite sides are equal. So the perimeter is just the distance around. To find the perimeter, we just, as the bold statement says up here, add the lengths of all sides of the object. So I have 2 plus 2 plus 4 plus 4. That gives me 12 centimeters in total. So perimeter is super easy, right? Probably the hardest thing is just learning the new word if you need it, if you'd never heard of the word before, or maybe you had heard of it before, but you didn't know what it meant. Okay, so 12 centimeters. Just for this lesson only, we're going to see some weird shapes for perimeter. We don't see these weird shapes really that much moving forward after this lesson. We stick to the form main, the rectangle, square, triangle, circle. But this is an odd looking shape. Determine the perimeter of this shape. Okay, I don't necessarily know if all sides are equal, but they've given me the lengths of all sides. So, and notice this is linear measurement because each side is just measured in one direction, right? So I have 4 feet plus 3 feet plus 4.2 plus 5 plus 3.4 plus 3.5. I'm just going to add up and make sure I got all my sides. Sometimes in an odd shape like this, it's easy to miss a side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It looks like I have them all. This little slash here, that symbol, okay, that means feet. That's the symbol for feet. It's an imperial measurement. This is the symbol for feet. Okay, so I'm going to add all my sides up. And let's see what I get. So I have 4 plus 3 plus 4.2 plus 5 plus 3.4 plus 3.5. And I get 23.1. And I can use that little symbol again, as long as I know what it means, right? Okay, another odd shape. Determine the perimeter of the shape shown below. Again, an odd shape. This one looks a little more familiar because it almost looks like 3 rectangles pushed together, right? Like rectangle 1, rectangle 2, rectangle 3. That's what it looks like. Now, also, it doesn't look like they've given me the measurements of all sides, but they have actually allowed me to figure out what the measurements of the sides would look like. So let's just see. This side is 6. And by the way, this symbol, this is the symbol for inches. So it's another imperial, from the imperial system of measurement, not metric. So 6 and 2 and 3 and 9, and I got a piece missing here. Okay, so I don't know this side, 8, 10, and then I don't know this whole big side. But they've given me enough information to figure out what this side is, right, I think? Let's see. I know that this whole piece, well, let's do this big long one first, from here to here. Well, it has to be the same distance from here and here and here, right? So I guess this side has to equal 8 plus 9 plus 2, because it's this side, and this side all together. So I get 19 inches. Okay. Now let's see what this little piece is here. If this whole side is 10, right? And what do I have here? From here to here is 6. I wonder if I can do this easily. And from here to here is 3, right? So that means this little piece from here to here, this little piece, this has to be 3 inches, right? It's not really part of my perimeter. I'm just using this to figure out what this side is. Because 3 and 3 would make 6. Therefore, this little piece has to be 3 inches. And if this whole side is 10, well, then I think in a long convoluted way, 10 inches subtract 3 has to be 7 inches. All right. So I'm going to say that this is equal to 19 inches, this whole long side, and this has to be equal to 7 inches. That was kind of tough, right? All right, let's find out the perimeter of this weird looking shape. It almost looks like the floor plan of a house, right? I'm going to start at 10 and I'm going to go clockwise. So 10 plus 19 plus 6 plus 2 plus 3 plus 9 plus 7 plus 8. Okay, lots of numbers that time. 10 and 19 and 6 and 2 and 3 and 9 and 7 and 8. I get 64 inches. Okay. Now there may be other ways to figure out that this was 7. I'm trying to think if there's another way to figure that out easily. I don't think so though. I think that would be, I think the way I did it's probably the only way. Or the easiest way. But if you have another way, you can chime in. Or if you found another way to figure out that it's 7, that's awesome. All right, so perimeter is just whatever shape you're given. They're going to have to give you the measurements of the sides. We're not using rulers, we're using the measurements given. Sometimes they do leave out missing parts, but they leave out, the parts they leave out are easily found by kind of working backwards and filling in the holes. But just because a side is blank doesn't mean they don't want you to use it. It just means they're being a little tricky. When you're asked to find the perimeter, you have to add up all sides, whether they're given to you or not. All right, so that's the perimeter. Let's take a look at special. You are required to be able to find the perimeter of a circle. And that's very interesting. The perimeter circles are so important in our day lives and in math modeling. They're very important. So we spend a lot of time on circles in this class because they're really foundational. Circles and triangles are very foundational to building and just to the way our world works. So the perimeter of a circle is the distance around the circle. That makes sense. But you can see that it's difficult to measure with a ruler. We don't have circular rulers. Now, one of the ways you could measure a circle is, I guess, take a piece of string and have the string kind of lay the string around the outside edge of the circle, which is called the circumference, and then just measure the string on a ruler. But sometimes we don't have enough string, right? Sometimes we're distance from the circle, so we can't even physically be near the circle. But as long as we're given the circle's measurements, we can calculate the circumference of a circle using a formula. So once again, the perimeter of a circle is so important it has its own name. And the only reason for that is because we have to use a formula. So just remember the circumference of a circle is just the perimeter of a circle. The circumference of a circle is slightly more than 6 times the length of its radius. So let's define a few things. In a circle, I'm going to just define a few things about circles, just to refresh your memory. Okay, all the way across the circle is the diameter. Okay, and the diameter is the distance across a circle, but you have to make sure you're running through its center, right? Through its center. So you can't just, the distance across a circle wouldn't be up here. That's actually called a chord. It has to be running through the center of the circle. All right, so now let's just talk about one more important measurement, the radius. The radius is the distance from the center, from its center to a point, any point on its edge, outside edge, okay? And you can see from the definition and from the pictures, the radius is half the length of the diameter. Or I guess you could say alternately, the diameter is double the radius. All right, so just keep that in mind. Now, going back to this, the circumference of a circle is slightly more than 6 times the length of the radius. The formula for circumference of a circle is 2 times pi times r. So the circumference of a circle, the formula is circumference equals 2 times pi times r. Remember from our previous polynomials units, if I just have symbols and numbers crushed together like that, it means multiplication. So 2 times pi times r. Now pi should be on your calculator, if you have a scientific calculator, and sometimes they're easier to see than others. I might go and use a different calculator if I can't find this one very easily. And it doesn't look like it can. So I'm going to use my graphing calculator, and I'm going to show you. You might have to look for your pi symbol a little bit. So on the graphing calculator, the pi symbol is just above the caret sign, right? The exponent sign. You can kind of look there. So it's right here. It's hard to see, but it's in blue. It's on the second row of function, so I'm going to have to press second. All right, let's find the circumference of this circle. So the circumference will be equal to 2 times pi times the radius, which is 10. Now, in the past, your teacher might have told you, oh, just use 3.14 to represent pi. But pi, the symbol pi, it represents the number 3.1415926, on and on and on. It never ends. It's non-terminating. So if you use 3.14, you're rounding far too much. So in this class, you have to use the pi symbol on your calculator. Otherwise, you'll end up with a rounding error. So turn my calculator on, 2 times, and then I get to the pi button, pi times my radius, which is 10. And I get this answer, 62.83 if I round. So 62.83 meters. Okay. Let's try the last example here. Determine the circumference of the circle shown below. Now, they're giving you this big hint. I think the hint is a little bit too much of a giveaway, but they've told you to recognize that you were actually given the diameter, right? And we're using this form of the formula, 2 times pi times the radius. So if the diameter is 6 centimeters, then I know that the radius is just half of that. Okay, I cut that in half and I get 3 centimeters. Okay, so to find the circumference, it's going to be 2 times the pi button times 3. So this time, clear my calculator out, 2 times pi times 3. And that gives me 18.85. And this will be centimeters. And that's it. Perimeter, and we're going to leave area for tomorrow or Friday, I'll see, but probably tomorrow I'll do the area examples. I'm going to leave it there today. And I'm going to ask you to work on assignment 2. Just try the first 2 questions for me, number 1 and 2, and that's it. I'm just going to leave it really short today so you can catch up. I'm still waiting for lots of tests from people, so I'm going to leave that there today, and I will talk to you tomorrow. Hop on email if you need me, or the live chat option here on our YouTube videos if you need to talk to me. I'll stay streaming for another minute or 2. And then if not, you can catch me on the email. Okay.